So just in case you haven't heard of this website, this is amazing for anyone who's doing A-level maths and further maths, Madass Maths, named after its creator, Trifon Madas. I hope I'm pronouncing that right. This is an incredible website with loads of incredible stuff in it, and one particular thing is called the Integration Megamix, which is found here. If I scroll down, there are quite a lot of integrals here, which are all doable. And I thought I'd do something very different today, and that I haven't really done before. I'm gonna go here and go from one to, in fact, no, the first 100 are quite easy. Go from 100 to like 750 or whatever it ends up with. And I'm just going to do one. So 387 is the choice that Google has made for me. So it'll be 387, which I could have used Control F. I feel like a dum dum now. It's this integral here. So that's 1 over x to the power half minus x to the power quarter dx. Let's get this bad boy out. So we're going to do the integral. I believe, if I remember correctly, it was 1 over x to the power of a half minus, I'm going to check that I got this right. If I go back, quarter dx. So let's have a look at this integral then. Let's check that that's correct. It is correct, it looks like. Good. So immediately I don't have any ideas at all of what to do. You could consider factorizing this, and then you could consider doing some kind of partial fractions. I don't know whether that would work. So for example, it would look like 1 minus x to the, like minus a quarter. That seems like a terrible idea. I don't know what I'm thinking there. Is it also a difference of two squares in some ridiculous way, like x to the quarter minus x to the quarter? Or you could bring out x to the quarter here, and that would leave behind x to the quarter minus 1. Is that better? Don't know. Is that better? Well, that's a difference of two squares, right? I don't know whether this would split up nicely though, even if you did all that, would it? I mean, this is x to the power 8 minus 1 x to the power 8 plus 1, I guess. I can't see how that would be helpful. So I might just delete this. The next idea would be a substitution, I think. Let's try something like u equals. Now, do we go x to the half or do we go x to the quarter? I'm going to go x to the quarter because that makes. No, am I? Yeah, I am. Because that makes this integral. I'll copy it from here. X to the half is this thing squared, right? Because when you square it, a quarter times by 2 is a half. So that would make this u squared. And like u squared minus u seems much easier to deal with. Of course, we have to deal with this over here. So if we differentiate both sides, we're going to get du equals dx times, I'll just put the dx first, times a quarter x to the power of minus 3/4, which seems pretty terrible, if I'm honest. Does it seem that terrible though? Because u to the minus 1 is u to the minus a quarter, and x to the minus 3/4 is a bit like x to the power minus a quarter, kind of all cubed, I think, which is u minus 1 all cubed. If I just kind of make the working look like this. So I think that's du is u minus 1 here. So that would be u minus 3, right? I guess. Okay, well, we can times everything by 4u3, and we'll put that over here. This looks easier to deal with, I would have thought. So the integral becomes, I can stick the 4 out there. The integral, and then I guess I can factorize out u from this guy. This might be the ticket. This might be the ticket. Should have done this first. And then the u3 goes here. And then finally we have the du. So this substitution looks pretty good at the moment. Obviously, there's some cancelling. I'll do that straight away, actually. Save me typing it up. So this looks okay. I think immediately I know how to do this kind of integral. It's another long way around, but I think we can make a second substitution, something like v equals u minus 1. And now du is obviously dv, so that doesn't make a difference. U squared is v plus 1 all squared. So let's just go straight in here. So u squared is v plus 1 all squared. And u minus 1 is just v. And then du was just dv because it's a linear transformation. And of course, when you expand this top bit out, you get v squared plus 2v plus 1, which all divided by v is going to make v plus 2 plus v to the minus 1, which I think all integrates very nicely. It's going to integrate to, I guess if I write equals, it's going to integrate to, well, v integrates to, so it's going to be 2v squared, I think. Plus 2, no, plus 8v, plus 4, of course, log v. So that's all that good to go. Now we have to put the first transformation in. So that's going to be u minus 1 in here and u minus 1 in here. Technically the last one needs to be kind of barred like this with a u minus 1 in it. So that's all that done. Ooh, this will be a minus there. And then we've got this transformation to replace with. So I think I'm just going to write the answer kind of in the middle here somewhere of, or every u is an x to the power quarter. So that's going to be there. It's going to be here. And then one more of them over here. I might make the whole thing red to make it more clear that that, I think, is my answer. I think you could just about read it if I put it there. Quite a fun integral. I guess you need a plus c. But yeah, shall we do another one? So after a quick break and a drink, I've decided to go for another one. Just my voice was hurting a little bit there. So if we go back to our random number and we go for a second one here, this will be 509. I'm going to press Control F this time because I'm better than that. Anyway, this is the integral of a log of 1 plus x squared. So let's just copy all this and delete everything, and then we can edit the question. I think it was log of 1 plus x squared. Cool. So okay, let's make a substitution of u equals 1 plus x squared. This seems to me like it would work. I can't see why this wouldn't work. Maybe I'm just being way too arrogant with this to start with. But this just seems like it would be. Oh, I can see what's going on here. I was being too arrogant. Of course I was. So this is going to be 1 over 2x into log u. But now obviously the log u is better. That's been improved. That's nice. Now 1 over 2x. Now x is, I guess, u minus 1 to the power of a half, because you take away 1 then square root. Which, I mean, this just seems like trash, right? This is not helpful in any way. So that was a bad idea, and yeah, I'm regretting being so casual about this. This is a horrible idea. It's really bad, just terrible. Don't think this is going to work at all. So okay, what we'll do instead is let's do, 1 plus x squared. So okay, if x was tan u, 1 plus x squared, 1 plus tan squared is, I believe, sec squared. So this will become sec squared, I believe. Now, of course, dx is what tan differentiates to sec squared. So sec squared u du. So this would have, I need to replace this here with another copy of sec squared, which also seems like this has gone badly. Maybe it hasn't gone badly. I think it has gone badly though. All I'm thinking here is that you can do some parts here, right? Because sec squared is really easy to integrate, so I can integrate that a couple of times for tan u, and then copy this whole sec squared business like this, and then we're going to take away the integral of, now again, sec squared just integrates to tan u. Now, what's the derivative of log of sec squared? Well, it's going to be a fraction, right? Sec squared on the bottom, and then whatever sec squared differentiates to on the top. Now, what does this sec squared differentiate to? Well, I guess it's cos to the power minus 2. So it's going to be cos u to the power minus 3. This has just gone really badly again. And then the derivative of cos is, I guess, minus sine. So I'll put the plus way over here, why not? And now I'll just say there's another sign here. But this is just terrible, right? This is, unless I'm missing something, this has just gone. Oh, this should also be a number here, right? Times by the power, so there's going to be a 2 there. Oh, but you also times by a -2, so that's a minus again. Okay, so I think that's all fine. This is terrible because this is, well, actually, is it terrible? This is cos, this is sec cubed. So that just makes us sec, which is 1 over cos, which is tan. So I think this is just tan squared, which is actually pretty nice. I can integrate tan squared because, as I've noted already, it's 1 plus sec squared. And both of those things are really easy to integrate because it's just, I mean, 1 integrates to u and sec squared integrates to tan. So this is 2u plus minus, sorry, 2 tan u. And then I think I just, okay, well, tan u is just x. So this is just x. Just putting these things back in. Now, I can't be bothered to deal with this properly. So I'm going to say this is arctan of x here. And likewise, just copy paste this. I think this is the answer. Why is it not? Okay, it's not letting me do that. Arctan x. You can feel the, and then tan u is just x. Feel the pain of doing this in PowerPoint. I think that's the answer. Took a little while to get there, but yeah, hopefully that's correct. There's definitely a thing wrong here. There should be another. Maybe that's why PowerPoint was messing around with it. I think that's some form of the answer. I think that's probably about right. Sneaky edit that I just noticed whilst watching this. This is, of course, I did all the hard work, did it all right, I think. But at a minimum, I don't know whether anything else is wrong, but at a minimum, this is definitely wrong because tan squared, 1 plus tan squared is sec squared. So tan squared itself is sec squared minus 1. And then you integrate that. So this becomes a -2 tan u there, and then it actually becomes a plus 2x here. And so, yeah, you end up with a plus here, I guess. And then tan, no, because the tan u was the x. So you end up with this thing going, these, they essentially swap places, right? So it looks a bit like this, I think, is the actual answer. Also, actually, sec squared u is 1 plus tan squared. So I actually, you could write this as, is this just 1 plus x squared then? Is that the cleanest way of writing the answer? Probably.